video, we'll meet Igor Rekun from App.build, an open source agent framework for building applications with LLMs. Igor walks us through how they replace complex Docker setups with Dagger, enabling blazing fast local sandboxing and parallel agent workflows.
Most of the agents, Cloud Code, up until recently Codex, 13th of June to be precise. So what they did is you have your model, like be it Claude, GPT, Grok. So you run it in your code base and it basically spits out tokens. So it has certain tools. That's basically how agents works. You expose it to run bash commands, you let it change files, read directories, etc., etc. So what they do is they work sequentially. So they generate it file by file, try to use certain tools, and in the end, what gets you is first, they can run out of context. Of course, there are tricks, and any of serious tools do certain context summarization to keep it in check. But anyway, the context sort of gets eroded over time. And secondly, the time to generate the app is bound until the model gets to the last file. And more than that, the agent can get into those infinite loops where it tries to do something, tries to fix, tries to fix, the fix is wrong, and it basically diverges and starts doing stupid stuff which gets no result. So on 13th of June, Codex finally added a feature which is called best of n. I wonder why it didn't arrive earlier, because it's obvious choice. It increases token consumption, because for single request you're now paying OpenAI 3 or 5 times more to get 5 completions in a row. But jokes aside, it makes a lot of sense, because when you do things models probabilistic by their nature, when you run a couple of completions, they are a bit different, and the chance of at least one of them succeeding is much higher than when you do a single completion. Now, that's the intuition behind what we do. So we run parallel completions from the start, tunable with oft research. And this brings us to the point. When you want to run completions in parallel, you need certain sandboxing solution that runs locally, because we could have gone for E2B or other cloud providers, but then you can't just clone our repo. You have to set up accounts in different services to sandboxing, auth, whatever, and it's not fully local. So we started with Docker, raw prototype, which was good for some time, but it had some of the problems because we were a little bit inflexible, let's say, in the choice of the starting point. So as you know, we can have starting point, Docker container, and then try to do something inside it. But it's not as fast when you try to modify the environment. You have to manage its life cycle, which was a little bit of, let's say, pain in the process, and grabbing the output. So when you run commands, we didn't like it that much, because when something, let's say, adds a spinner progress bar, like Drizzle running migrations, you sometimes get a blanket of lines which shows updates. I started looking for other solutions, and one of our product guys, David, suggested a call with you guys, and I thought there is something in it. Maybe we should try it. And that's basically when we fell in love. It's very convenient to build dynamic environments, so we can build it from scratch, modify it's compatible with Docker, it runs on top of that, basically same infrastructure supported, but it's good at caching. So during our researches, we have to keep pointer to the Dagger container, and that's it. We can restore, we can start branching from any point in time. So basically we are migrating to web UI. It's fresh, so it's not prod ready yet. We used to have CLI like Claude or Gemini. We decide that it's limiting what we can do. That's the simplest prototype I have right now. I started build me an application to track my gym workouts. Asks me what I want to do. Set reps duration date, sets reps weight, and let's see. All right, it doesn't want any more information from me. And what happens under the hood? As you can see, it starts with draft generation. What it means is that basically we are not generating application sequentially, file by file. What we have under the hood is a little bit more interesting. So our agent starts with types, database schema, and main handlers. And the handlers are just function declarations. And what that allows us to do is, as soon as we have the types and the handlers, and it passes the checks basically, like the types are correct and it satisfies our certain linters and invariants, then we can not just branch and tree search what we have. Yeah, so what we can see is we have the schema, the database schema, and the handlers. And here is the draft. So right now, the agent starts to generate all the handlers, as you can see, in parallel. And that's where the beauty comes from. Right now, the way it works is tied to, not really tied, it's a little bit of expertise and our like internal heuristics, because we know how to modularize application to let the agents work in parallel on handlers. And then when it converges back, it still plays together. Now, next step is to make it work for any template, not just what we have for our full stack, which is basically TypeScript throughout and TRPC, and basically go from there. So right now, in this demo, we have full stack applications. We can generate like dashboards using nice UI and Python, sort of like data apps. And in the next release, I hope we will have more general solutions that works for like any tech stack. I can't promise the dates precisely, but I hope before end of summer. All right, it's working on the front end right now, and that takes some time because we validate the visuals. We basically run Playwright and take screenshots to make sure the application really works. So as you can see, all the handlers completed in parallel. And what it is we also have tests for all the handlers. And the reason is because with tests, we can see that the data model and the functions that basically handle the routes are atomic and easier to unit test than when you have like one humongous application with zero structure, and then that's become like more complex. All right. Basically, what we have is probably one part of interest is the base actor and the base node. Very short file, but basically that's the core of what we run on. It's familiar to every computer scientist data structure and the actors that we derive from. Obviously, we have the Dagger workspace, and then your common tools: delete, edit, write file, and read. We don't need anything else because we highly structure the access and restrict what the agents can and can't do at certain part. And we have the depth and beam width, basically how deep and wide it can search. Extra tools that you can add. And so far, if you drop into, for example, the agent that generates data apps, so what it needs is basically the function core, which is called by the state machine execute, which basically collects the context. But the core is here. The function select, if we go and look what it does, basically checks the tree and sees if any node can be branched or needs to be branched. And we don't have a solution yet. Basically returns the list of nodes that need expansion. So what happens later is we just run completion and get the new message like with tool calls, all the stuff that language model generates. And then we run evaluate node. So like eval node is where the Dagger comes into play, because it first runs tools, and tools require access to the workspace. Secondly, it decides if the node is explicitly marked as ready, and then it runs checks. So if you go and see what those checks are exactly, like for example, for Python, it's linter checks, Playwright checks, tests, and then SQL model migrations. And the cool part about that is, first, when the actor, let's say, encounters a problem and can't complete in the end, we start branching more aggressively, because that's exactly the part where the agents often get stuck in the loop. But when you seed it and say, all right, now try 3 different ways to finally get it right, the chance of success is higher, but it increases number of containers we run concurrently, and it still does fine, because if we actually look at the stuff that we are doing, some of those checks are like pretty advanced deployments. So we run Postgres, which gets attached to the container that we run tests. Well, the impact was definitely speed of development, because we didn't have to fight with Docker that much and could focus on the backbone, in a sense, how we specifically do the LinkedIn checks and what we want in terms of features, and not fighting infrastructure. Because in my opinion, when developing agents, the infrastructure is main like stumbling point for everyone, because just building an agent, you can write implementations for Cloud Code tools like text editing, replace read directory, and it's going to be within, okay, not within speed and distance of Cloud Code, but pretty close. The only part that's missing is the way you run retrieval over the code base. So that's like where the main competition is, how you do like grep, is it vector search versus lexical search, and basically nudging language model towards reading right parts of the repo. Aside from that, it's all infrastructure. And basically, and part of the reason like many of the tools don't have any research ideas implemented yet, because it takes a lot of effort to get the infra right, and just to get it work through all like the Git repo, file system stuff, merge requests, PRs, and to get it to work. So that's that. The next, how to do that for any tech stack, let's say be it Rust, be it Ruby on Rails, Laravel, whatever. And here comes Dagger, because first, our agent will have sort of internal CLI, which will run locally if you want to develop it for like stack we don't have a template for, which is the whole point. And it needs a sandbox to tell exactly what it will do, but it will need access to your repo to sort of bootload and devise how to modularize it and find a way to change parts together that then can work together properly.
App.build is pushing the boundaries of what agentic code gen can do, and with Dagger, they're doing it faster and locally. Want to try Dagger for yourself? Head to Dagger.io and join us on Discord. We'd love to see what you build.